In this video we have some indefinite integrals to evaluate, and for the most part these will involve a U-substitution. So for the first one I'm going to let U equal to 1 minus cosine of x. Then du will equal to the derivative of 1 is 0, the derivative of cosine of x is minus sign, and you got a negative in front, so that'll make this a positive sine of x. This will be dx here. And then we transform the integral into one involving the variable u. So here is the sine dx, and that's the same thing as here du. And the denominator, the 1 minus cosine of x, is u, and it's the square root of that. So this will be the square root of u. And now we just integrate with respect to u. This is the same thing as u to the 1/2, so if I take that to the numerator, it changes the sign of the exponent to negative 1/2 du here. Basic integration then, add 1 to the minus 1/2. That'll give me a plus 1/2 here. And then divide the coefficient by 1/2. Give me a 2 here. Plus the constant of integration. And that's basically it as far as the integration goes. Then just go back to the original variable. This will be a 2. And then 1/2. Again, we can write that as the square root of u. But u is 1 minus cosine of x. And then we have the constant of integration. And that's it for number 1. Number 2 looks kind of similar, but can't do the same thing here. I'm going to let u equal the sine of x. Then du would equal to the derivative of sine is cosine of x. I have my dx here. And for number 2, put an equals here and transform the integral. So again, here cosine dx right here is the same thing as du. So I can replace that product by du. And then it's 1 plus sine of x is u. And it's squared, so this would be u squared here. This is u squared. And this is just the formula that leads to the arctangent of the u. So I could put an a squared right here. And the formula is du over a squared plus u squared is equal to 1 over a. In our case, a is 1. So it'd be 1 over 1. It's just going to be 1. And then it's arctangent, or you can write it as tangent inverse. So it's arctangent, tangent inverse here. And then this is going to be u over a. Like I said, a is 1, and of course u is sine of x, so sine of x over 1 is still sine of x. And it's plus the constant integration here. Again, this part right here could be arctangent of sine of x plus c. Okay, the next one we have x over 16 plus x squared. And you think of this, well, that's a rational expression. You might be thinking of partial fractions. But notice the derivative of 16 plus x squared is 2x. Very convenient for, again, the U-substitution. So I'll let u equal to 16 plus x squared. Then the du would be derivative of this. 16 would be 0, and x squared would be 2x. And I have the dx. So divide through by 2. This cancels here. Then I get a 2 over here. So then we can transform this integral. The x dx right here, I can replace it by du over 2. So it's integral then of du over, and then the 16 plus x squared, that's your u. And of course this was du over 2, so I'll just put the 1/2 out here. And then of course this is one of your typical integrals here. Integral of du over u. 1/2 goes along for the right, it's constant. It's the natural log of absolute u. But u is 16 plus x squared, and because we have a plus x squared here, this can never be negative, so I don't need absolute values here. I just put parentheses. This will be 16 plus x squared. And it's plus the constant of integration. So 1/2 natural log of 16 plus x squared plus the constant of integration is the solution for number 3. Now for number 4, again I can use a U-substitution. Let u equal to 1 plus e to the negative 2x, and that's the denominator. Then du would equal to the derivative of this denominator. Derivative of 1 is 0, and for e to the minus 2x, it's going to be e to the minus 2x. And then with the chain rule, derivative of minus 2x is a minus 2, and then it's dx here. Divide both sides by negative 2 here. The negative 2 cancels on the right side, and we get e to the negative 2x dx is equal to du over negative 2. So we come back over here then and say equals to the integral e to the minus 2x dx, that's this product in the numerator, is du over negative 2, so this will be du. The minus 1/2 will be, put it over here, and it's over here 1 plus e to the minus 2x, but that's your u. Again, same formula we just used. This is going to be negative 1/2, and the integral of du over u is the natural log of absolute u. But this u, 1 plus e to the minus 2x, cannot be negative, so I don't need absolute values here. I just put 1 plus e to the minus 2x. So the answer for this one then is negative 1/2 natural log of 1 plus e to the minus 2x. And of course I have the constant of integration. And that's the solution to that one. For number 5, you have tangent of 1 over x, and you got x squared in the denominator. Looking at ahead here, I can say, well, u equal to 1 over x. You can think of this as x to the negative 1 here. So take the derivative, comes up, the negative 1 comes to the front, subtract 1. So this is going to give you a negative 1 over x squared. And then this will be a dx here. So notice here, I have dx over x squared. So this is multiplied here by a negative 1. This will become a positive here. And on the left side, this will be a minus. So let me rewrite the integral now in terms of u. So with this information now, we can transform the integral into one involving the variable u. So here I have then tangent of 1 over x. So this would be tangent of u. 1 over x is u. And then the dx over x squared right here, that's the minus du. So the minus comes out in front. And I put the du over here. Now we just integrate with respect to u. So I have tangent of u, integral of tangent of u du, the minus out in front here. And there's a formula for that. Actually two, one involving the cosine and one involving the secant. I use the one with the cosine here. So it's integral of this right here is natural log of absolute cosine of u. And it's plus the constant of integration. Double negative here, so that's going to cancel out. And all you have to do is go back to the original variable now. So it's going to be the natural log of absolute cosine of 1 over x plus the constant of integration. Final answer there. Thanks for watching. We'll see you next time.